Science for Everyday Decisions, series by Center for Sustainable Development at the Earth Institute, Columbia University. For your consideration for a more sustainable life through education for sustainable development.
On this call, especially to give us tips on how to make our homes and how to make our schools energy efficient. She works for an organization that focuses on making, energy efficiency. Welcome, Sarah. Thanks for giving us, some time. And we are just a very formal group here. Couple of us work at Columbia University, and we have this Eco Ambassador program that we run in many different parts of the world. But just because of time limitations and things, we can only have at 4 p.m. EST, and so it becomes a little late for other places. We have John, who's joined us from Rwanda, and then we have all our Eco Ambassadors who join us from New Jersey and elsewhere as well. Especially given that it is such a difficult time, we've not been, very. There are many different components of our program, but given that we need to be connected, and given that because of this COVID-19 problem, it's just become very obvious that we really need to do something about climate and sustainability in general. So we've ramped up our activities and especially online discussions for our youth and eco ambassadors. Usually we do this once a year in presence conference. So now we are, because of the place that we are in right now, we are using technology to have these interactive discussions. In a way, it's good and bad both, but I feel that it's working for us for now. So thanks, Sarah, for joining, and I'll let you lead our discussion and maybe take questions at the end.
That sounds good. So I was thinking today, just before I introduce myself, that I would just share a little bit about SolarOne, the nonprofit organization where I work. I have some slides I can share on the screen for anyone who can see. And then I'm going to focus on different things that you can do to become more energy efficient, as you mentioned, both at home and in schools. So thank you again for having me today. Happy to be here and meet all of you virtually. I work for a nonprofit organization called SolarOne. I've been there for 10 years. So we are a New York City-based organization, but we also work with schools in New Jersey, primarily in Newark, New Jersey, and we also work with schools in upstate New York, and pretty much all of New York State. So our organization was founded in 2004 with a goal of helping to make New York City more resilient and more sustainable. And we do that through a couple of big programs. So I am quickly going to share my screen. All right, can everybody see that?
Yes.
Thumbs up. Okay, great. So SolarOne, we have 3 major programs. The first program is called Green Design Lab. That's our K through 12 program. Our second program is our Green Workforce Training, where we provide hard skills training for adults. We have a solar program. We actually manage a native plant species park in Manhattan along the East River. And we have a Clean Energy Connections program where we have 4 events a year down at the WNYC, and that's our local NPR in New York City for folks who are not from the city. They have a green space in Manhattan. So the first program I'll talk about, and I think could be interesting for some of you thinking about climate and energy, especially folks who do live in New York City, is our Here Comes Solar program. So the goal of that program is to help make solar accessible to all New Yorkers. We primarily work with affordable housing providers in the city to help install solar on a large scale with many buildings around the city, and we help get a lower cost by doing all the pre-development work on that. The Here Comes Solar program has helped install, I I can't remember exactly how many megawatts, but a really large amount of solar here in the city over the past 5 years. And one of the exciting things that we have been supporting that I would like to talk about a little bit with you all is something called community solar. So you may have been walking down the street or gotten things in the mail or gotten phone calls asking you to switch your energy provider to Clean Choice or some other source of renewable energy. But oftentimes those actually, what that means is that you pay your bill and some of the money for your electricity use actually goes towards renewable energy that's somewhere else. So it's still good for the environment, but it's not local to New York City. What's cool about community solar is it allows you to subscribe to a large scale solar installation that's here in the 5 boroughs of New York City. And instead of costing a little bit more money, which many other renewable energy opportunities do, it actually saves 10% a year on your electricity use. So I'm signed up for a project right now, and I saw a big drop in how much money I was spending on electricity. What's cool about these projects is that oftentimes renters in New York City and people who live in buildings that are taller but don't really have a good roof for solar or not a good candidate to have solar, you can still access it. So to sign up for community solar with SolarOne, the only thing you have to do is be a Con Edison customer in the 5 boroughs of New York City. And yeah, you can sign up. It supports a local solar installation, which also usually leads to local job opportunities. And it saves you 10% a year on your electricity costs, which is major. So I'll make sure at the end of this discussion that I send you guys the link so you can learn more about that and share it with people you know. So we work with a lot of partners on that. Those are just some of the nonprofits that we're helping to get solar with. So our Green Workforce Training Program, that is a training program mostly for adults. And we have a training lab in Long Island City with a hands-on space where we offer workshops in green building operation and maintenance, green construction, which focuses on carpentry, electrical, and plumbing, solar installation, and then we also provide a lot of industry certifications. So these are certifications you would need to get into solar or any of these different industries. The way we do that is we don't actually have any programs that folks can sign up for. We work with existing workforce organizations throughout New York City, and it's a partnership model. So we work with an organization like St. Nick's Alliance, and they actually bring us cohorts of students who are interested in getting trained, and then they do job placement after the training is over. So they actually help place people in careers that we train them for, which is a very cool model. This is just a picture. Again, I mentioned we manage a native plant species park for whenever school does open again. We offer really fun plant ecology and water ecology field trips because we're along the East River in Manhattan. And finally, our K through 12 education program. So our K through 12 program is called the Green Design Lab. And the idea is that we provide curriculum and programming for schools with a focus on sustainability. So our largest curriculum is our energy curriculum, which we have a K through 5, 6 through 8, and 9 through 12th grade unit for each. We also have content that covers water, materials, food, climate, and air quality. The way we usually deliver that is through teacher training, after school and summer programs, and then we do what we call classroom residencies, where we actually come in and co-teach in the classroom alongside typically science teachers for 4 to 5 classes a day. One of our major programs, and I'm mentioning this one now just because we're hoping to have some webinar opportunities for this coming up really soon. If you sign up for our mailing list, you'll get a notification about it. But we work with the Department of Education to connect solar installations on schools to classroom curriculum. So what we typically do is provide 2-day in-person trainings where we support teachers on how to use SolarOne's curriculum in the classroom. But given the current circumstances, we are planning this spring to offer some additional webinar trainings where we'll talk about web-based resources all focused on solar and energy that you can bring into your classroom, and we'll really go through step-by-step how to get that done. So that's a little about SolarOne, and I figure what I can do now is jump into just some basics about electricity and energy efficiency and things that can be done in schools and homes to make a difference. So electricity is something that we use every single day, whether or not it's something we're really conscious of, right? So we all know we plug in our phones, we're using these laptops. I've never done so many Zoom calls in my entire life as I have in the past week. But it's more than that. The fact that we can live in an urban environment and have access to fresh food because we have refrigeration. The fact that we have traffic lights, the New York City subway system, which runs 24 hours a day and operates entirely using electricity. So all of these things that we do require electricity to work, and yet so many of us have no idea where our energy is coming from. So most of the electricity that we use is generated in a facility called a power plant or a thermal power plant. And they typically burn oil, coal, and gas, or fossil fuels. Now, New York City no longer, and actually New York State pretty much no longer burns coal, which is the dirtiest fossil fuel, which is a good thing, but we still do have quite a bit of natural gas and some oil. So the way that that works is that we extract fossil fuels from the earth, which has its own negative impacts on the planet. And then we burn that fossil fuel, and we use the heat energy from burning the fossil fuel to boil water. And when we boil water, steam is produced, and the force or pressure of that steam spins a turbine, which is pretty much like a giant fan blade. And that fan or turbine is connected to a generator. And a generator is usually two magnets surrounded in copper wire. They're spinning, right? So we have that spinning turbine, it's spinning the generator, and it's actually generating a direct current of electricity. So that flow of electrons along the conductor, that is what electricity is. And then we're sending it out through transformers, it goes out into the power grid, and eventually ends up in our homes and in our schools and in our offices, and that's what powers everything that we do. So the problem with burning fossil fuels is that really, if you look at global greenhouse gas emissions, electricity in the United States remains the second highest source of greenhouse gas emissions, second only to transportation. And globally, agriculture is pretty high up, but electricity, transportation, and agriculture are always our top three sources of greenhouse gas emissions, no matter what. And the way that we're producing electricity, it gives a lot of air pollution, right? Smoke, particulate matter. And that's the stuff that can cause lung disease, asthma, all kinds of respiratory issues. In addition to air pollution, it's also a major factor in climate change, as I just mentioned. So this is just a cool infographic from the New York Times showing New York State's electricity sources, which New York is pretty unique compared to a lot of places. We have quite a bit of nuclear power, a really significant amount of natural gas, but most importantly, we have a lot of hydropower. So hydro makes up 19% of the state's energy resources for electricity. So how do we save energy, right? So the big thing about electricity generation is that the power plants are only generating as much electricity as the grid demands. So it is a direct connection. When you turn off lights, when you save electricity at home or in your school, it directly impacts the amount of fossil fuels being burned at a power plant. So there's a lot of things that we can do as individuals that can make a really big impact as a whole. One thing is to purchase a watt meter. So a watt meter, I usually tell teachers, I say, like, I suggest buying this for your home and then using it as a classroom resource as well, because it's so practical. They're about $20 to $25 on Amazon. I really particularly suggest that one in the picture called Kill a Watt. That is a very easy one to use, and it'll help you understand exactly how much electricity the appliance is using. So when we talk about watts, that's the unit of measurement that we're using to understand how much electricity an appliance needs to work at any given moment. So if you used to buy light bulbs at the hardware store, they would say, oh, this is a 60-watt light bulb. That means that that bulb itself uses 60 watts to work. And if you add in time, right, it would be 60 watts per hour. So you can multiply that out by how long the device is left on. So the cool thing about the kilowatt brand watt meter is that if you just press the button in the middle, you can get an instant reading saying the wattage of that appliance. But let's say you're testing something like a refrigerator, and refrigerators are often a big source of electricity usage in a home or an apartment, and they turn off and on. The motor kicks on and off all day. So you can press the pink button all the way on the right of that meter, and that'll actually track the appliance's usage over a day, over a week. So you can check it at the end of a certain time period and figure out exactly how much it used. So all you have to do to use it is plug in an appliance and record the data. And if you don't want to wait to test things over time, you can actually, just by guessing about how much something is left on, you can make a pretty accurate assessment of how much electricity it's using. So let's say we were in a school and you had a 100-watt desktop computer that sat in the classroom. And you asked the students and they were like, you know what, I think that that computer is on and running for an average of 4 hours per day. All I would have to do is say, all right, that means it's 4 hours at 100 watts. So that's 400 watt hours. But any of us who have ever gotten an electric bill, we know that they are measured in kilowatt hours. So if there are 1,000 watts in 1 kilowatt, that means that our computer is using an average of 0.4 kilowatt hours per day. And if this was in a school, you could very quickly multiply that by the number of school days in a year and figure out how much electricity one single device is using over the course of an entire school year. So it's a great exercise in thinking about how much electricity different appliances in our homes and schools use. And it's also a good way to get an idea of which devices are really important to start with, right? So once we figure out which appliances are using the most energy, those are the appliances we can focus on when we're thinking about behavioral change. One other thing I want to add is that if you, because of the crisis, if you can't get a watt meter right now, another way to do this is to actually look up appliances by their model number and just look up what the wattage is. And you can do the same exact analysis that I just did without doing an actual test. And you can run through and try and figure out how much electricity different appliances you're using around your home, your apartment, or your classroom. So let's think about lighting, right? So in school buildings, lighting actually continues to be the largest source of, or it's really the highest amount of electricity in the building is typically lighting and then the kitchen, right? So all the refrigeration and the cooking that happens uses a lot as well. But lighting is a big deal. So there's lots of different types of light bulbs, and you can identify them usually by looking at them. So the first is incandescent. You don't really see those around anymore. That's the original Thomas Edison light bulb. And those are usually the least efficient. So they use the most electricity to work, and they don't last very long. So they burn out probably every few months. They have to be refrigerated, or they have to be replaced. The second type of light bulb is a compact fluorescent bulb, or a CFL. Those are the swirly ones. So the CFLs, they're pretty much like a tube fluorescent, just smaller. They last a lot longer, so they last usually like 6 months. to 2 years even, depending on the bulb, and they use significantly less electricity. So for example, you can see in the chart, a 12 to 15 watt CFL can give you as much light as a 60 watt light bulb. In schools, we have tube fluorescents mostly, so those you can see are usually either a T12 or a T8. The best way to identify that is by looking at them visually and seeing if they're about a little over an inch wide, or if they look really skinny in the ceiling, because the skinny ones, those T8s, are far more energy efficient. The Department of Education in New York is slowly switching to LEDs. I think New Jersey is probably planning to switch to LEDs as well, but it's a slow process. Another light bulb to keep an eye out for, especially in schools, is high intensity discharge lights. Now, these are lights you're going to see in the auditorium. So if the school's custodian engineer is leaving lights on in the auditorium all day, some of those lights are using 1,000 watts. So that's a really good area for reducing energy. If they're allowed to turn those off when the auditorium is not in use, it can save a significant amount of electricity. And finally, the most energy efficient and most common light bulb you find in a store today is the LED, which stands for light emitting diode. So LEDs, they can last 15 to 20 years per bulb. So once you invest in these, you don't have to buy them again. And really, to get the amount of light from a 60 watt bulb, you are looking, this chart actually should really be updated. You're looking at like 8 watts of electricity. So LEDs are really the most efficient. You can get them in different colors and they're super bright. One thing you'll start to notice when you're buying light bulbs is that we're moving away from using the wattage as a way to tell how bright it is, since it really doesn't anymore now that lighting is so much more efficient. And what you'll see is a measurement of lumens, and lumens tells you exactly how bright the light bulb is, and that is a better way to assess. Something else that's interesting is that young people don't need as much light as adults. So you can think about, you can actually download apps on your cell phone that are cheap or free in some cases. They're light meter apps that a photographer might use. And you can actually measure lighting levels in different areas and see if the space is over or under lit. So you can see if your kitchen maybe is too bright, you could get a dimmer bulb. Same with your classroom. So you can actually take your cell phone and hold it at the desk level and actually measure the amount of light hitting that desk surface and see if the room is overlit. Now, if the classroom is overlit, you might do something like turn off half the lights in the room during the middle of the day, or roll up the shades and use natural light instead. So lots of things we can do at school. There's actually a student using a professional light meter to do that same activity, but we can advocate for switching light bulbs. We can conduct an energy audit, like I said, by measuring things and then making suggestions. So how do we increase awareness about this? And how do we inspire others to save energy? One thing to do is to do a poster campaign. And I think another way to do this now that we're living in this digital environment is to consider making a social media campaign, an online poster, a meme, something that could be shared on the internet about why it's important to save energy. Another thing you can do is look at electricity data from the school. The New York City Department of Education's Office of Sustainability does have access to some data. It's historical about that. Or you can try and work with the custodian engineer once we're allowed back in school buildings to actually read your meter on a monthly basis and graph that data. Letter writing. So one thing I did that was really fun at a couple of schools is that we were working with campus buildings where there were multiple schools in one building. So students wrote persuasive letters to the teachers and staff from the other school buildings, explaining why they wanted to save energy and including some facts that they learned from their audit and what they thought was important about saving energy. and then they put them in their mailboxes. So that's another thing you could do via email, is spread awareness about why it's important to save energy and share resources about it as well. So my final tips are focused on ways we can save electricity at school, easy methods. One is to unplug appliances. So you might have heard of something called phantom energy usage. That is when you leave appliances plugged in but turned off. Some of them, not all of them, but some of them use a lot of electricity. One of the worst offenders for phantom energy use in school buildings is the smart board. And another similar thing is really any projector. So projectors have a little lamp that they keep hot so that when you turn them on, you don't have to wait a long time for it to load and get bright on the screen. So a lot of times projectors and smart boards actually are using, even when they're powered off but left plugged in, they're using about 10 to 15 watts, which is a lot. So if you unplug appliances, you can also use something called a smart strip, and a smart strip can actually tell when the appliance is not in use and cuts off power to it automatically. Or just a power strip. If you have a power strip with an on-off button, and you switch it off at the end of every day, that's just as good as unplugging the appliance. Another tip is to use natural daylight whenever possible. Open shades, turn off lights. Try turning on only a portion of the lights. Another big time to unplug is before a break or the summer. Using a fan instead of an AC whenever possible, especially in the winter. I beg not to use ACs in the winter. I know the classrooms can be hot. Use student audit data to increase energy awareness at the school, whether that's through morning announcements, videos, letter writing, posters, making a TV commercial, all the things we discussed. Turning things off. That definitely makes a difference as well. Leaving things on, even in standby mode, especially computers, it's really not good for your computer. It is better to turn it off. Leaving computers on all the time is not great, and your phones as well. So turning things off helps use less electricity. Talk to the custodian engineer about turning off lights at the end of the day, especially in large spaces like the gym and auditorium, and use Energy Star rated appliances wherever possible. So that is the end of the slides I prepared. I hope that that was helpful to folks, and I'm happy to take some questions.
Radhika, you're on mute.
Sorry. So thank you, Sarah, for your presentation. And I think I have to memorize all the points because some of them were so new to me that I feel that I have to memorize it, and some of them are common sense. So, but I have not been doing it, in my house, especially the computer turning off. I think definitely we can, try doing that. So thanks for those tips. This we just for everyone's information, we have recorded this presentation, and we will be sharing this presentation with everyone, because I know once the school starts, we might want to get back to looking at the slides again to see what we can do, and maybe 3 things that we can do class presentations on, or something that we can do during assemblies, I think will be great. So thank you for that very useful presentation. Are there any questions from anyone? ARICO ambassadors?
I'll start off with the questions.
Yeah, go ahead.
Hi, Sarah. Thank you so much for the presentation. I know you mentioned you were encouraging students to talk to the school and maybe the management about switching over the light bulbs to LED. So I was wondering why the uptake of that from the school system is very slow. Is it because of the supply? Is it because getting the LED lights is not actually compatible with like structurally whatever lighting they have at the schools? What is the reason for the slow uptake?
That's a great question. So it's tricky because several years ago, the Department of Ed started implementing in New York some big changes around energy efficiency. So New York City is the largest school district in the entire country. So 1,800 school buildings, which is quite a bit. And they have done a lot of switching from the T12 to the T8 fluorescent, which is a big deal. And one other thing I didn't mention that they've been doing and that every school is going to get at some point is something called vacancy sensors. So they're not actually motion sensor lights. They're lights that sense when no one is in the room for 20 minutes, and then it turns them off. So that's another big thing, but you are correct about the infrastructure for LEDs. So while switching bulb ballast from one type of CFL or one type of fluorescent tube to another is not that challenging, the LED fixtures are still much more expensive. And so I think it's a big financial hurdle. So I think right now they're focused first on finishing the installation of all of the vacancy sensors, and then they'll start the transition towards LEDs, which it'll be a lot of money and it'll be slow, but it will happen. So unfortunately, that's something that happens at the citywide level. So it's not in the power of the custodians in the school themselves. So the things that are more that you can change on the ground are much more related to turning things off. So behavioral change from the school staff, but also the custodian again has the power to change things, like turning off lights in the auditorium or turning off lights in the gym when it's not in use. And they also have a lot of power over making smaller improvements that improve heating efficiency in the schools.
Mm-hmm.
I was wondering, has your organization, kind of along these same lines, do you have data on costing of some of these things, or like when is the break-even point, depending on how outdated the infrastructure is, for when they would see some savings actually because of the more efficient bulbs?
That's a good question. I don't have any of that data, but it is out there. I know in smaller districts, it's actually much easier than in New York City, because in New York City, the schools themselves don't see any financial savings because they don't pay their own energy bills. The energy bills are paid centrally by the city agency called DCAS, which stands for the Department of Citywide Administrative Services. So, but in a small district, you're seeing a lot more schools pursue really advanced technology for energy efficiency, like installing LEDs, because that turnaround, the return on the investment is so much faster, and it actually impacts the school's budget to spend on things like teacher supplies and computers and important things we need for learning. It's also why we're starting to see a big uptick in schools going solar around the country, which is very exciting because it also saves financially, depending on what state you're in and what kind of solar policies you have. But I talked to a school in Connecticut recently that went so far as to a public school. They had installed sensors that tracked if people were in the room by looking at carbon dioxide from people being in the space. So it's really, there's a lot of cool technology out there. And I do think you can, if you look online, I think there are resources that show the return on investment for something like upgrading to LEDs, but I actually don't have.
Thank you so much. This is very informative. I just was asking because I love that idea that you shared about the persuasive letter writing. And I was just thinking, some of those little factoids in there might go a long way to convincing the right people, but probably a lot of research has to be done about district size and all of those things too. So we have our homework.
Yeah, and I think that's a great, especially for like a middle or especially a high school student, to work on figuring out what the return on investment would be and how long the payback period would be if you invested in LEDs. Let's say if you just took the number of ballasts in each classroom and multiplied that by the number of classrooms and looked at the total cost. And then if you were able to get a copy of the school's electricity bill, you could actually calculate it out and figure out how long it would take to earn that money back through energy savings. And yeah, that would be extremely persuasive, like to send to a school board and be like, hey, we figured this out. If you invest in LEDs, you're going to save money.
Thank you.
Hello.
John, and then Alok. Yes, John.
Thank you, Sarah, for sharing. You mentioned at one point that you go into classrooms, and I was wondering in what capacity do you go in the classrooms? Is it an arrangement at a school level, or it is a central program? Because sometimes it's not easy to go into classroom, because in most cases they have tight timetables, and they tend to not have enough room for such programs. So it requires talking to other ministerial institutions or the district, in our case, to allow you to do that. And what I've realized is that most of what is being done is what you're doing is on awareness creation. And of course, this goes with the discipline on how to use energy, electricity, so that we could save. So, and for us, the way we've been doing it here, although it has not been, the uptake has been so slow. And mainly it's because people don't really understand how much they can save by using this in terms of the cost and also the protecting the environment. So there is what we call co-curricular activities here. And most of these other programs that are sort of cross-cutting, we take them as co-curricular activities, not integrated in the curriculum or in the timetable. In most cases, it is very hard for our schools to take these programs serious. The second alternative is to influence curriculum so that it is integrated and also put into the school timetable. Could be either under the environment studies or all science, or it could be a standalone program itself. So do you have plans of having this integrated in the curriculum, or what you're doing so far is you think it would be okay to scale up to other schools the way you're doing it?
Yeah, I think it's interesting. I think the energy efficiency piece is definitely more of like an add-on. It's we find a lot of success with clubs, like after-school clubs, green teams, where students actually sign up to do this on their own time is really effective, especially around pursuing energy efficiency. Some of the other curriculum that we do, especially the solar curriculum, we find it's a little easier to fit it into the core curriculum for science. So we do that for earth science because we will just directly connect it to things that are covered in the earth science test or what's in the curriculum to make it really fit. So for example, thinking about how a solar panel needs to be placed on a roof, and why it has to be angled a certain way because of the Earth's relationship to the sun and where you are on the planet. So that's the kind of thing that we do when we're going into classrooms. But yeah, I hear you that it can be challenging sometimes to fit these important environmental topics into the core curriculum in the school. And I think it's a matter of thinking of like when you teach. So one thing, here's another example of how we fit our programs into science. So one of the topics covered at both elementary school science and in middle school is energy storage and batteries. And actually, not even that, just electricity and circuits, right? So a lot of students in schools are learning how a circuit works. They're learning about how electricity works, and they're building a simple circuit using a battery and a motor. So one way we can infuse the environmental education into that is to use a solar panel instead of that battery. So it's the same exact lesson, but we're just going to use a solar panel and talk quickly about the benefits of solar power. And that way it fits in instead of being something that's an add-on. So it's all about looking at the science curriculum overall and figuring out where does it make sense to talk about energy efficiency and the environment that it would fit in instead of being something extra. But if it is something extra, to really consider a club or a program that's outside of the normal classroom time. Especially when you start doing an energy audit of the school, if you can get your hands on watt meters and stuff, when you're doing that audit, doing that with a club is much easier, because then you can go after school, and it's much easier if you have 1 meter and like 10 students going around and measuring things, as opposed to trying to facilitate measuring appliances with 30 students in 45 minutes. So I hope that's helpful, but yeah, I definitely hear you on the challenges with.
Right.
Hello?
Yeah. I just want to ask, like, does it require like major, like if you want to install like solar panels on like a relatively small sized or medium sized school, would it require like major changes in the infrastructure, in the energy infrastructure of the school, or, and if so, how much would it cost? Like if it's a mid-size, if it's like a small to mid-sized school.
So it totally depends. Interestingly, one of the biggest factors for installing solar on any building, including schools, is the age of the roof. So when you install solar, you want to have a roof that's been repaired relatively recently. Most New York City schools, and actually schools around the world, the rooftops often have to be replaced or fixed up like once every 10 years. So let's say your school roof hasn't been repaired in 7 years. It's not a good time to install solar, because you would have to take it all back down. So that's one factor. Another factor is that there does have to be some infrastructure upgrades to the meters, to the electrical wiring, but that's not usually prohibitive. It's just something that has to be done in collaboration with the local utility. So New York City is installing solar on a large number of school buildings. You can actually look up and see which school buildings are solar ready. There's like a solar ready list that I can share after this call through the Department of Education Office of Sustainability for New York City folks. But people outside the city, a really cool tool if you want to see if your school is a good candidate for solar is Google Project Sunroof. So Google Project Sunroof, you can actually type in an address and it'll show you an infrared map of your roof and give you some estimates of what it might cost to install solar, if it makes sense to lease it or buy it, or what some of the different options are. So there's a lot of cool online tools out there that you can use.
Yeah, thank you.
Hi, Sarah. I have a question. My name is Will. I'm a high school teacher, and I've got 4 students who are working on a green roof project, and they're looking to build one prototype green roof and then one traditional tar paper black roof, same dimensions, and they want to see whether or not the interior temperatures during, let's say, the summer differ between the treatment versus the traditional, and see how that might translate into energy expenditures. And I guess I was wondering whether or not, is there any way that I might be able to connect them with you or resources on your end just for feedback on their project ideas, and maybe even ways that they could get involved with existing projects in the city?
What school do you work?
I'm actually in Long Island. So
Cool.
yeah.
Very cool. So yeah, definitely you can point them towards me. I will say I don't know how to do that exact calculation, but I do know that their results should be very promising, that a green roof will dramatically cool a building compared to a black tar roof. We did an experiment with some high school students a few years ago, going even further, where we actually looked at solar panels and how efficient they were if they were put up on a green roof amongst the plants versus just being on a black tar roof. And the thing is that while solar panels, they use light to work, not heat, and they actually, if they're too hot, become less efficient. And so the solar panels that were installed on the green roof that had like sedum, like just low-lying plants, actually were more efficient and produced more electricity than the same solar panel that was on a tar roof. So there's a lot of cool and great reasons to go solar or a green roof. They're both really beneficial energy-wise. As far as getting involved with solar projects, that can be a little bit tricky. Just we do an internship program, and we find there's a lot of steps to get students up on a roof for safety reasons. But I do think we could definitely share resources that connect to just where solar is being installed across New York State, so they can learn more about it.
Great. Thank you very much.
Any other question? So one question from my end, and very tangentially related. I grew up in India, and there our moms used to use solar cookers. So, but I don't see them here. It's a great way of cutting down on electricity usage, as well as also great way of using some natural resource for cooking. But I don't see them here, so maybe that's not a technology that people use here. And also my second question is, the solar panel installation seems a very expensive proposition. So maybe cutting down on electricity and making sure that the tips that you gave, I think probably are the best way to go about things in the households. What would be your advice?
Yeah, for sure. So first, on the solar thermal energy, yeah, there's not a lot of solar cooking here, but there is solar thermal power. So in the Southwest, there's actually giant solar thermal power plants that use heat to generate electricity instead of solar panels, which use light. And they look very cool. They use giant reflecting mirrors to actually boil water, just like the regular thermal power plant. There's also solar thermal is used really widely for hot water heating. And you can do that in cold environments too. They're trying to expand it in the city. It's a little tougher in an urban environment, but we are seeing it in the suburbs for sure. People installing solar hot water heaters outside of their house, running across their roof. It's such an easy technology because all you really have to do is pump water through copper or any kind of piping on a hot black roof and pump it back into the building, and it's hot. We did a test with students outside heating hot water. It was maybe 40 degrees out that day. And within 10 minutes of testing our system, we got the water temp to rise by like 25 degrees. So the power of solar thermal is awesome. And there's a lot of really cool DIY projects you can do, building your own solar cookers, building your own solar hot water heaters, tons of resources on YouTube, great projects. As for the solar installation, yes, installing solar is very expensive, but I can't stress enough that everyone should look up community solar in their communities. It's available in a lot of states around the country now, not everywhere, but a lot of places have it. And it is for any renter, and it saves you 10% a year on your electricity use. It's a big savings, and it supports local solar. And then finally, just on tips at home. So my big tips are starting with the refrigerator. A great project to do, and I actually just did this at my house, is to vacuum out the back of your refrigerator. Refrigerators get very dusty, and it dramatically reduces their efficiency. And if you look behind your fridge and there's sometimes like a little metal grate, if you can take that off and get like a dust buster or a small hand vacuum, and vacuum the dust that has accumulated on the fan blades, you will really improve the efficiency of your fridge. Another thing to think about with refrigerators, especially if they're old, is to check the seals. The seal on your fridge, if it's cracked or torn at all, it's letting that air escape and it's costing you a ton of money and wasting energy. Finally, an empty fridge is not good. Same with an empty freezer. So you're better off storing jugs of water in the fridge than having it be empty, because it takes more energy to cool empty air than it does to cool food and liquid, which actually holds that cold temperature in. Other things to do at home: swap out to LEDs in all of your lighting fixtures. Make sure you are turning appliances off. If you have a video game console or a cable box or an Apple TV or a Roku, really any of those televisions, computers, all those devices use phantom energy. So especially if you're leaving, I mean, not that any of us are going anywhere anytime soon, but if you're leaving for a little while, really think about turning all of that off with a smart strip, or a power strip, just pressing that off button, or unplugging things. Other thing is to really, especially with heating and stuff, to make sure that in the winter you can seal up your windows. You can buy really thin film clear plastic. It's super low cost, and use a hair dryer, and you can actually seal your windows to keep the heat in. That helps quite a bit. Turning lights off when you leave a room is always a good habit. I'm notoriously bad at that, but it's super important. And yeah, just watch out for all those phantom energy use things. Buy a watt meter, and also make sure to clean out your air conditioner filters. And whenever you're buying a new appliance, especially if it's major, like an air conditioner or a refrigerator, make sure it has that Energy Star rating, because a new Energy Star rated refrigerator might use like 200 watts. But if you buy one of those super fancy refrigerators, it has like a touch LED screen on it that I've seen in some houses, those things might use 2000 watts. So just because it's new doesn't mean it's energy efficient. It has to have that rating on it.
I mean, I've not really been careful about what I'm buying. What does energy rating meaning? Like, does it have like a symbol that we need to look at, or like the blue colors? I don't know. What does it look like?
Yeah, so it's a little blue. Let me just quickly put a link to it. So this is the logo you're looking for. And this, if you see this logo, whoops, hold on, give me one sec. I'm just copied the wrong thing here. Oh, this is not working. I was thinking I could just drop it into the chat, but I can't. But it's Energy Star logo.
Okay.
So anything with that blue Energy Star on it means that it's definitely energy efficient.
I think if you go on like Lowe's or Home Depot website, you can filter for appliances that have Energy Star rating too. So that makes it easy.
Great. I think we have been, at least I have been missing a lot of important information. I just want to run down and look at my fridge and see what's going on behind. And then I do have an empty refrigerator in my basement, so I'm going to do something about it. So these are excellent tips that which are very because sometimes, you know, when I think of so in Melbourne we have this green team, and they have said that we'll have next year. This year was zero waste, and next year was any energy efficient, making schools energy efficient. And the topic itself was scary, because what does making schools energy efficient mean? So it's great that, you know, we got you at the right time, and you've given us simple tips that we can use and do small projects on, as well as at home, to see, because sometimes also, you know, taking understanding the concept takes a lot of time, and then plus what can we do given our busy lives and given all the other things that are going on around us. It becomes one more thing to do, but these are simple tips that doesn't require a lot of time. It just requires us to be conscious about it more than a time investment. And I think all our students are here, eco ambassadors are here. Maybe we should invest in these watt meters and see what we can do in each school. And having data and having us present to the schools is going to be much more effective than just giving a long speech on what we should be doing. And so it can be a school project that we can do with data and graphs and other things. And if we can put a dollar amount, I think everyone is going to be super happy to see, oh, if we need to do this is how much the money, how much expenditure goes down. I think that's going to really make a lot of difference in terms of convincing schools, and in terms of convincing our green team and other things, other team green initiatives that are going on in town. Are there any questions from anyone?
Yes, just a quick one from me, especially on the sustainability, where this solar electricity has been installed. Because just to share in a second our experience, one of our schools that was far from the grid, we had to install solar. But there are two challenges that we faced. One was on the initial cost. It was huge, but we covered it. We subsidized as a project to support the school. But later, it became a challenge for the school to maintain. So I want to learn from her if they have that monitoring program to ensure that whatever is being installed is used to save the energy as it's planned. And then what are the sustainability plans in case they're out? Are the schools in position to keep using these panels? What is the maintenance cost that is involved in that? Couldn't it be even more than, for instance, hydro, in case someone applies those measures of using it in a disciplined way, as she has been saying? So maintenance later could be a challenge as well.
Yeah, absolutely. I think maintenance is a big thing. And I think early on in the solar world, there was not much attention paid to maintenance. A typical installation usually lasts about 20 to 25 years, but it does need to be maintained properly, which means that the solar installation companies doing that work have to train the folks in the buildings that are maintaining those systems, like the custodians and the building managers and operators, on how to use them, how to clean them, how to repair them. That's not something we do because we're just a nonprofit, and really each system is designed and installed by the company that puts them up. So they really have, I believe it's the company's responsibility to make sure that happens, because it's very important that they have access to training and information to make sure that those systems still work and that they're maintained properly, especially if you're talking about school buildings that are off grid, because an off-grid system means that your solar panels are connected to a battery and they're charging the battery up. So that's a whole other system that has to be monitored. And oftentimes the batteries, the solar panels outlast the batteries. So oftentimes if there's issues, a lot of times it just means that the battery has to be replaced. And sometimes you can just replace them with car batteries. That's like a cool way to hack it. But yeah, it's super important. And I think it wasn't happening as much when solar started to get popular in the last 10 years. And I think recently it's gotten a lot better.
All right. Thank you.
I have a question.
Yes, you can. Maybe last question and then we can, thanks.
What exactly is a watt meter?
Great question. So a watt meter is W-A-T-T. And the watt meter is a device that you plug your appliances into. So you could plug your TV into it, let's say, and then it would tell you how much electricity your TV is using at that time to work. So it's like a way of testing how much electricity an appliance needs to work.
Okay, thank you.
Thanks, Ishika, and thanks, Sarah. Really, really very inspirational, and you've given us what we need to get on with being a little bit more energy conscious. We'll see how much we are able to accomplish from the scale of 1 to 100, but at least there will be a start from our end because of your conversations and because of your discussion. So thanks a lot, and I hope it's all right for us to bug you a little bit more further along to see if we can do something in the school and if you can give us some more advice. Sarah, we can't hear you. Sorry.
Oh,
Yes.
It was great talking with you all. I just threw in just a link to one website selling that watt meter I talked about, but you can find them for anywhere from $15 to $24, and they're really, really helpful. But yeah, thank you all so much, and let me know if you have any questions, and I hope this was helpful.
Very, very helpful. Thanks, Sarah. And one more last thing I wanted to let everyone know. Tomorrow we have a call again at 4 o'clock on public speaking skills. And here is the website. Here is a Google document that I just started on getting your reflections on a particular article. It's a Guardian article and really interesting article. So it would be great to get all of our eco ambassadors to respond to the article and get us reading and also get some reactions on this particular article. Thank you so much, and we'll join again tomorrow at 4. Thanks, Sarah.
Thank
Bye.
you. Bye, everybody.
Thank you.
Thank you. Bye-bye.
Bye, John.